Great. Well, thanks very much for the opportunity. And I would like to present something which has been developing alongside system dynamics with a little bit of, let's say, a direction towards planning. And I have been for 25 odd years, 25 plus years, I have been working on both system dynamics or systems thinking as well, and also planning. The planning at the time when I started that was about, there was some methodological innovation in the 80s and 90s really. And this was the environmental impact assessment, which it's from the 70s, but then in the 80s it picked up a little bit of momentum. So what this did was to make explicit the planning procedures, and especially around the outcomes, like forecast of outcomes and the assessment of outcomes. Until then, and in many areas which impact assessment is not necessary by law, whoever plans, they have a lot of freedom, they exercise all this freedom, and they don't commit themselves to neither formalities of objectives and actions, nor outcomes or assessments. So this formality brought in by, or permitted by the impact assessment procedures, it gave a little bit of opening to the planning, or maybe explicitness to the planning procedure, to the planning operations. And at the time, in the early 90s, I was always exploring how things, how can we say we understand how things work before we set off for a plan. And this is where system dynamics is crucial, is to understand how it works, how the system works, before we figure out where to intervene. And at the time, in the early 90s, I thought, gosh, what I'm doing is so simple, so trivial, and I proposed it here and there, conferences, and loads of colleagues, and well, 30 years later, almost 30 years later, it's very simple in theory, but it doesn't. People are so busy in their own things, and okay, either they say, okay, this is planning, and I don't care how the system works, but I'm going to plan, or they say, well, I do care how the system works, which is pretty much systems people, but then again, the plan doesn't get all this formality that it probably should. So this is the bridge there. Okay, between one and the other. I tried to make a bridge, and of course, the first time and the second time I presented that, people had a lot of questions. How does it work? How does it not work? And I had to be, presenting and convincing people how it might work or not. And I've been quite patient and diligent on this for 25 or maybe close to 30 years now. And here, this systems planning is the, let's say, hybrid between system dynamics and planning. So I'm trying to make it simple, as very simple as possible, as simple as possible. And I would like, first of all, to start with the roots, the system dynamics, and the common things with system dynamics. And I wouldn't go any further than the CLDs, causal loop diagrams, or cause and effect diagrams. In fact, this is not the particularity of system dynamics. It's something shared with system thinking as well, which is cause and effect diagrams. And maybe I should start illustrating. I would like to fast forward to the systems planning modeling language because we don't have much time. So I'm forward. Okay, maybe I should click one after the other. What I'm going to go to is the lab, systems planning lab, and then I'm going to go into the technological advance, or T advance, and then one of the options says language, which is the SPML, systems planning modeling language. And then I'm clicking on this, and it takes me to the T folio, or technical folio, which is this. And a folio is pretty much, it's an old-fashioned scroll, and that's why it has the color of a scroll, like parchment or so. And it's about 2 meters long. So it's not a book format, it's not an article format, it's a scroll format, which is, sorry, okay. Is that a message for me?
Just real quick, Tasso, we have another PhD student who's joined us in my office by the name of Jim. He works in Big Pharma.
Okay, great.
Just so you know, there's another one.
Okay, thank you very much. If I'm going too fast, please let me know, and I'll go slower. So up to now, I have been clicking maybe a little too fast, but there's an easy way. For example, if someone wants to go straight into this, also there's on the top right of every single page, there is a little box like this box, and if one types language, that should bring the results right there. Oh, sorry, but I cannot load this here because we have security issues. So I'm going to go into technical advanced language, SPML, and language. So what I was saying is, sorry, these are the rules. Okay, this is about systems. The language is divided in systems, processes, and plans. These are the three main sections. And the fourth section is markup, which makes some difference, as I will explain. So I was thinking, this looks familiar to system dynamics or systems thinking, which is a CLD, causal loop diagram. I call it a generic, generic is because this is generic, but they're called reverse blueprints. And the reason they're called reverse blueprints or RBPs is because usually we have a system that is given to us, and we have to figure out how it's put together or how it works. And so we're trying to figure its blueprint, but in a reverse way. First, we have the system and then the blueprint. So this is the common thing with system dynamics and systems planning. And on top of this, yes, hello?
I don't know if others have this issue, but I see a blank screen.
Oh, I don't see a blank screen. So let me refresh.
Yes, we have a blank screen too.
Oh, I'm sorry. So what do you see now?
Yes, I see artwork collection and
yeah, okay. So let's try again. What about now?
Blank screen.
Nothing.
Oh, so that doesn't work. So the PDF cannot be displayed, although I can see it. So I'm going to try something else. I'm going to try, this is my backup, this plan B. So iCloud Drive, and I'm going to say language. What do you see now?
Yes, I see the PDF.
A long strip.
Yes.
Right.
Yes, very small. Yeah, it's getting bigger now.
Right.
Yes.
Which scroll, as I was explaining, it's about 2 meters long by the width of a single printed page. So this is the whole thing. But okay, we cannot, as we tried to zoom in with Christine before, we cannot zoom in too much on this, just about this much, which should be enough for now. What I would like to show you at the moment is this. Well, in the middle of the screen, there's looks like an eye, and it says element A, element B connected by a plus and a minus arrows, right? Generic blueprint.
Yeah, we can.
Feedback now, please. Can you see the construction in the middle?
Yes, we can see it.
All right, good, thank you. Right, so this is the common ground, let's say, between systems thinking, system dynamics, and also with system planning. Now, on top of this, the difference, I mean, what systems planning is putting formally on this is a structure of the problem. We do mention the problem, and it's essential in system dynamics and also systems thinking. The problem is really important. However, what comes up in systems planning is the expression of the problem, the formality of the problem in 3 elements. And these are in a mnemonic way, X, Y, and Z. And I will just give it, sorry, there's a markup session here, markup section. Markup, yes, text markup or TMU. And what I'm looking at is the XYZ positioning. Is it good enough to read, or maybe not? Can you read?
I
where
think
it says,
we can see it.
Okay, great, thank you. So there's a technical issue here that I cannot stretch it anymore, but I'll keep it like this. Sorry, my screen, yeah, I'll try again. Okay, so the X, Y, and Z are the elements that define the problem in the systems planning terms. So these are, it's a markup to be next to each element, as you can see in the new I here below, just below the 4.2, just before the 4.3 section. It's the same structure with an X and a Z on it. So the idea here is that on top of the classic CLD or RBP in this language, then we have to mark, necessarily we have to mark our relation with the situation, with the system. So in this case, we are marking on heating that this is where the action will take place. That's the X. And X is almost always for planning, it's the unknown. What do we do? So the X is where the action should take place. We're not saying yet what we have to do. This is yet to be figured out, but at least we're guessing where we should be acting. And the Z is it's marked on the temperature, and that means this is where our objective is. Objective is like the end or the desired end, and the Z is the end of the alphabet. So that's part of the mnemonic. And of course, there's the Y out of the X, Y, and Z set. So the Y is, well, why are we doing this? Why are we bothering? It's a higher concern. And the higher concern is an aggregation of all the Z's usually. So this X, Y, Z is a markup. It's the classic markup for systems planning to express and define, express the problem or the parts of the problem. And these have to be marked on the causal loop diagram. So this is one difference in that the formality and the obligation to mark. This is not the only way to mark things, but this is the native systems planning marking. Since I mentioned an alternative marking, I would like to show, first of all, if you can see by the bottom of the screen, I'm not moving it too much, we can even add values to it. So if you see at 4.3, after the table, there's the I again, and it says, just below temperature, it says the objective, which is 20 degrees Celsius. So we can also add numerical values to things, to objectives. And objectives, if they are taken or attributed by different stakeholders, they may turn into obligations. For example, for one stakeholder, whatever is an objective, for the other, it could be a condition. So they could be requiring this, and the other is trying to figure out trying to get there. And I'm going to release a little bit now. And I would like to connect again to the SWOT. There's an alternative, there's an alternative markup, which is the classic SWOT analysis. So on top of this I, now the subject changes, but the construction is the same. On top of this basic diagram, I'm sorry, I released that. We can also accommodate S's and W's, so strengths and weaknesses. So this is an alternative to the native XYZ problem markup. In this case, in the SWOT, we only use the S and the W as starting points. Then we have to make another diagram to accommodate the opportunities and threats. I'm not going to go into depth right now, but just to say that there's an alternative markup to the native X, Y, and Z. Of course, there will be others. There can be others, but this SWOT is quite popular. So this becomes a graphic SWOT. Right. And at this point, I would like to, I mentioned one common, which is the CLD, or in this case called RBP, which is the diagram, and something which is on top of the common, not common really, but builds on top of the common ground, and that is the formality of the problem that can be expressed as XYZ elements, or even as a SWOT or SW requirements, or let's say markup. So just to start with, and I would like to ask if anybody would like to ask anything, or maybe I went too fast on a presentation point. A little feedback if you want. If you don't want, I carry on.
To me, a real quick question. In your causal loop diagram here, I saw that you use the goal only at the value, but from the graphic, do you explicitly show the goal? In this case, heating and temperature, you know, having a link from this variable, the goal and the temperature, to really explicitly show, you know, the discrepancy between what we want and the current state of the system. And then there you have the corrective action, which is somehow balancing feedback loop.
Okay, thank you very much, Suleiman. It's a good question. It's a natural question. Thanks for expressing it. At this point, I must explain one more difference between system dynamics and systems planning, which is on purpose. Systems planning is not doing all of this numerically. It's doing this qualitatively. For example, we could state a discrepancy, we could state a concern on the discrepancy, but, and of course we could add a diagram if we have, or a graph that would explain patterns. This is all additional, but the point, I mean, the reason why the numerical is held off is because the intent of systems planning is to for people to understand or stay at how things work and how the problem and how does this relate to them, so they will keep at the problem, and the solution, or perhaps the next step to do, that would be to make an action plan. And I didn't go into this, but I will go. So if somebody needs to see numerically, yeah, system dynamics is the way to go. Well, that's why I'm saying they're complementary. Okay. And I'm keeping systems planning, at least at the moment, well, for many years, but I'm trying to keep people to focus not on the numbers, not on the values, but really on what they should be doing for something that they understand how it works. So if anybody insists on numbers, system dynamics, no, hands down.
Yeah, okay, thank you.
Sure, thank you. So I mentioned the plan, and I will go to section 3, the plan, instead of 2, which is the process, and then we can go to the process. In fact, as we spoke with Christine yesterday, just warming up to this, and the system, the process, and the plan, they don't have a specific order of appearance. So as one feels comfortable, first you can start with the plan, you can start with the process, of whatever you feel comfortable with. Eventually, all 3 they have to be displayed, and the problem will show up marked up on all 3 of them. Now, the native location where the problem is structured as it should be is the plan. And this, I'm showing, okay, this is the plan, and there's the table of all the semantics, and this in the middle should be now a diagram, a cyclical diagram. Is that okay for everyone? Can you see the cyclical diagram? Yeah. Okay.
Yes, we can see it.
You can. Thank you very much. At some point, when especially with the technical issues, I would appreciate your feedback, especially if it's a blank screen or a non-visible item. So this diagram is a plan diagram or descriptive causal diagram. It is a causal diagram, but it has 3 different lines. These lines are in line, excuse my pun, in line with the generic, or actually what I'm showing again in the middle. If you see where it says, a footnote says variance, descriptive or is a straight arrow, or an arrow with a straight line, and then the stochastic, or it may be, is a dashed line, and the normative, which is must be, is a kind of sawtooth arrow. So this is throughout the language. In this case, we have another line as well, which only applies to this descriptive causal diagram, which is a kind of like a spring kind of line. So we only have the dashed, the solid, and the spring line. The spring line is, as it says here, it's an effect, or in fact, it's a feedback. Sorry, it's a feedback for the plan. And I'm going to go from the top from 12 o'clock to 3 o'clock to 6 o'clock and to 9 o'clock. So if we start with a concern, or the why are we concerned, why are we bothered here? And then we reason, and that's the dashed line. We are reasoning to say, well, if we are concerned in general, then exactly what do we need to have, or what are we looking for? So we have to concretize this concern, the why, into one or more objectives, which can be measurable, they can be more specific and understandable, and more concrete, if you wish. So what does the concern mean in practice? And then this is how we develop the Z. And once we have the Zs, the Zs, then we're trying to say, okay, what is the good action, what the right action could be to achieve those objectives. So this is an inductive process, and we're looking for options. So what could be, and of course, how we look for that is very variable. This inductive step here, it's kind of left out of the scientific paradigm. So it's like, it doesn't matter, in the paradigm at least, it doesn't matter how you come to a hypothesis, just give it to us and we have to examine it. But this is the real deal here. We have to figure out, we have to be, in a sense, knowledgeable, intelligent, and creative to figure out which action could satisfy our objective. So this is practically looking for what to do, and the techniques here for looking for that are quite variable. But eventually we do get there, and we are trying to figure out what.
So, do we got a question?
Question.
Yes.
So I'm looking this. So you're calling this a planning, kind of a planning language or planning approach, and you have all of in your this little simple diagram. You have objectives through some actions.
Yes.
So, so to me it's not obvious without another method that you would know that those, and maybe it's going back to what Suleiman said about doing some other kind of test and modeling with system dynamics or something like that, but to take the ideas and say what actions you believe. I mean, how do you, in this planning language, I don't see the connection to those actions. How you get those results? How are you going to get those results?
Mike, I'm sorry, the sound hasn't been very clear. So you're looking for the connection between the actions and what's upstream?
The outcomes.
You gotta talk through my computer.
Oh, yeah. I haven't said anything about this yet. So once we have the action, then we start the simulation. Is that okay? Can I take it from there?
Yeah, that's okay. Go continue. Thank you.
I didn't want to go too fast. So yeah, you kind of, you went a little faster than me. So, okay, once we have the action, then we simulate what could the outcomes be. And as I mentioned, these simulations are qualitative and they're not numerical. Oh, this could be combined with system dynamics here to produce numerical outcomes, but mostly it's what people think. I mean, people with experience on the subject think that an action like this could bring about. So it's like which outcomes are likely to appear after a certain action is applied on this element, on each element respectively. And so we come up with a set of outcomes, the Z prime, which in principle are exactly as the objectives we had set before, the Z. So that's why it's called Z prime, it should match the Z. And here is the first comparison. Once we get the outcomes that we found reasonable, excuse me. This is the first comparison is whether they are close to our objectives or not. And of course, again, qualitative. Right, so this is the first comparison, and the second comparison would be, do they satisfy our major concern? So the outcomes are compared to the Z on the right, and they're compared to the Y to the top, to see whether the outcomes which are forecast are likely to satisfy our main concern and or the concerns if there's more than one, and also whether they match our objectives. Maybe we have gaps, and this is exactly one of the points where impact assessment. In fact, you can see the impact assessment spirit here, because the outcomes sometimes they have side effects, And well, if we don't think of the side effects, they will appear not to be there, but eventually they will be there, and that's a surprise factor. Not exactly a welcome thing in planning to have surprises. So this concludes the circle. And okay, Mike, your question is about the link of the how do the actions link with the outcomes. I believe I mean I hope I have said that it's a qualitative simulation. So.
Yeah, that was from Jim, our PhD student. So Jim, is that accurate? Yeah, he's shaking his head yes. Yeah.
Sorry, I confused the voices. I'm sorry. But is that okay for now?
He's saying yes.
Yeah, okay, thanks a lot. Right. So this is the plan view. And of course, this X, Y, and Z, they will be on the system model here. They should be. Well, they're not yet, but in the markup, we saw that they are right here. So there's another view, a third view, which is functional. It's stepwise, and it's a linear. Usually, it's chains, those processes, and it's an alternative view to the system, to the cause and effect view of the system. So this alternative and complementary view of the system, it's not how one element of the system causes a change to another, but it's a procedural view in a way that we see how does one state receive an action to take it to another state. So it's a state, action, state, action, state, action change. And this is common in engineering, and so in a sense, let me see, like state, action, or the opposite can be action, state diagram. So I call them concise process diagrams, and they can be extended process diagrams if we add more detail. For example, if we add methods to them. We can even have them as personalized process diagrams if we add who's doing what, and then we cut, we tailor the diagram for every operator, which can take a little more detail, but the real basic structure is action, cause, action, action, state, or state, action chains. It's an alternative view, it's an operational view, let's say, of the system in a procedural way. And this may help to identify in the way we are doing things, the procedural way we are doing things, or maybe nature even, maybe we can identify where, at which point, at which state we are not happy, and maybe we can put an objective there, or maybe we can identify which action is not being carried out well, so we can put, let's say, an objective there, or perhaps another X, so we can refine the action. So this serves as a complementary way to figure out, let's say, where our objectives could be. And this has worked out well in cases, in applications, in real cases, that if people see a system or they're trying to figure out the system, maybe they're not so likely to think of a system because they're not used to it, but sometimes they're more likely to see a process that they may be more familiar with the process. But then once we see either the system in a cause and effect way or the same in a state action way, then we have to switch and see the complementary way. So both of those try to help people figure out how things work in a causality way and also in a procedural way, and mark the problem again. So this is a natural stop, at least looks to me a good stop to have questions or perhaps comments if you wish. We have seen the language and the three elements of the language, the objects actually of systems planning, the system, the process, and the plan, and also markup options. Any questions at the moment? I don't see any. Should I proceed then? Christine?
Yes.
Yes. Okay, right. what I would like to show, maybe I would like to illustrate a little bit on examples of applications of this. So I'm going to share another file. Projects. All right. Can you see this new diagram on the screen?
I can.
Okay. So I presume all the others will also be able to. This is from a project on higher education institution, and one particular an institution of higher education, and this is on enhancements. And these are concerns. The nodes here around the circle, they are concerns. They are not exactly quantifiable nodes. For example, if we say pedagogic competencies, it would be an oversimplification to say like 35 units of competence or points of competence. That would be an oversimplification. So these are left as non-quantifiable. I mean, they're quantifiable, non-measurable items. We can say 35% or so, but it wouldn't be a good idea to start attributing units to something so abstract. So it goes abstract. And these are the concerns. This is how the project starts. And we have a few connections. If you see there's a gray, I don't know how the colors render on your screens. Can you see a gray, light gray between, let's say, the 10 o'clock and the 11 o'clock point, nodes?
Yes.
Light, yes, okay, thank you. Sometimes the colors don't render the same on different screens, so I'm glad, okay, this one does. So this connection, if you see it says education on the side, so these two are concerns of education. And then on the right, like the 1 o'clock and, okay, the 1 and the 2 o'clock, it says understanding. And the other one says administration and an extension. So this is how it starts with the concerns. The question would be, for this project, it would be how do we improve and how do we enhance those states? Now, the work is not exactly, we do see a few loops here, how things work, but there's more to be explored in the following. So I'm going to switch and show another one. These are selected slides from that project. So this one is particular, well, it has two concerns on the left, organizational, cultural, and administrative efficiency. And this goes from the why, the abstract, to the concrete, which are the objectives on the right. So this column on the right of the concerns, that is the objectives, that this, it's more like, it lends itself better to measuring. It makes more sense. It doesn't shock, at least, when we try to measure, let's see, good examples. We could say number of examples, or coach study, hours of study, case study, design, some unit as well. So these are more easily measurable or countable anyway. So this goes from the left to the right. And then so we have the Y gives rise to a Z. Actually, the top, the green one, the green Y gives rise to 3 objectives, requires good examples. So organizational culture requires good examples, coach study, and case study design. At least this is claimed that it is. As always, these are my mental models, and it's arguable that they could be different. Of course, they can be different according to the way that the team thinks or the team has the experience with. But once we have this, let's assume this is okay, then we have the requirements that what organizational culture requires those 3 objectives, and then we explore for each one of them, what is it necessary to do, what do we have to do. Therefore, so for good examples, then we have to visit selected cases. You see in the action, the X column, which actually both both columns are highlighted with a brown box, or they're inside a brown box. So the top brown box has the label staff development, and the bottom box is operational readiness. So the top action group, it has 3 nodes, and the nodes are double. They have the object and they have the action. And this is typical of the diagram. So when it comes to the action, the nodes are double, and we have the object that we are going to apply the action, and we have the verb of action. So the reading is from the bottom to the top, if you wish, but we could then invert. I mean, it's not necessarily bottom and, I mean, the top and bottom can be inverted, and it's all right. As long as the convention is carried out in this particular diagram or the set of diagrams, it's fine. So we have to visit selected cases, we have to train the process for the processes, and we have to set up design. So with these actions, now we simulate. If we visit selected cases, this will increase the experience in administrative issues. At least it's claimed that it will be. And if we train for the processes, that is going to increase organizational understanding. And if we set up design, then also increases organizational design. So this end is highlighted as yellow because there's synergy there. So it's more than, I mean, 2 actions are going to contribute to that. So there's a little bit, it's more than we expected. I mean, if we have like the addition of those, the synergistic effect of those actions. So this is only for illustrative purposes, so I'm not going to go through the whole diagram, just go to the top of the diagram. Then there's an interesting loop there with the result of the lower part. But just for the top, and just to conclude, we have to go, we see also that the administrative experience also is claimed to increase organizational understanding. So there's 3 things that enhance organizational understanding from the top part, and there's another one from the bottom, simplicity. So in a sense, we by this action that is conceived here, we're creating organizational understanding and creating a little bit of experience as well. And both of those, both organizational understanding and experience, are likely, or at least it's claimed that they're likely to enhance the organizational culture. In this case, we can see in which way, in which sense the culture is being enhanced in understanding and some experience. If we wanted to contrast this outcome, the Z prime or these 2 Z primes with the objectives, we could as well. It is not here done. It's just it's enough that it satisfies the objective. We could, if we wanted, as an aside, but then it may become a bit complicated. We could, as a side operation, we could see whether we have a gap in our objectives or outcomes. But then again, this is only the technicality. The point is that the outcomes should satisfy the original concern and that there's no side effects, which doesn't appear to be. So with this diagram, this is the plan really for this particular issue, which is organization and administration. From this, we can go to another section or another department, if you wish, like science or all those 5 items that were on the side, and we can see after doing all of those, carrying out all of the plans, we can see the final result. And then this is where I'm going because we only have 15 more minutes. So the final,
quick question.
See. Yes, please.
Yeah, do you also capture the delay here into this diagram? Because I think, for example, the administrative experience, to increase it at the desired level, this might take some time. So is it a way to capture that, the delay in the diagram too?
Yes, of course. In the same way that CLDs, this is also a causal time. So we put a double line. Actually, I put a D on it, a D for delay, and on the arrow that the delay is meant to happen. Yeah, it is possible. And well, it's not written on this diagram just because it was not considered at the time, I suppose. But yeah, since you bring it up, yes, it is possible. It is advisable as well. Yeah, it's a good idea. So thank you. So can I just share the last one, the final? Okay. Okay, this is the last, it's the summary. And this shows, if you look at the inner circle, it is exactly as we had it in the beginning. And the outer sectors are the outcomes of all these actions. So this is, it is summarizing what the expected outcomes of the actions will be, or are calculated to be, or are meant to be, and in which way those actions are going to enhance the original concerns. So this is a summary diagram for if we follow exactly as the plans were, like what we saw before. There's 6 or 7 of them, and if we bring them all together in this synthesis diagram, we can see if there's any conflict or any synergy, and there are synergies, those yellow nodes, and also we can see in which way those expected outcomes are enhancing, or maybe not enhancing. In this case, they are enhancing the original concerns. If you notice on the right of each word, enhance or enhances, there's a star. And this star indicates that this particular statement, enhance or enhances, is a subjective statement, as opposed to an objective, like increase or decrease. Objective means it's measurable, or at least it's calculable or measurable. But enhances, it's a judgment, and it's subjective. But at least we get to differentiate. I guess it's a good idea to get used to making clarifications between objective and subjective statements. So this is a summary diagram of the project. The actions are not here. The actions are on each plan. And this one is just the summary to see if overall the plans are interacting between themselves, because we have to separate them, because usually these are attributed to different departments, like scientific department, or education department, or research, education, administration, and so on. And we want to see if all the plans tie in together, and if they enhance really what the concerns have been. Just one of the examples of an application. So we have 10 minutes, 12 minutes. And I believe it's not enough for another example, but it's maybe good enough for a small discussion. Or questions to start the discussion. For instance, do you see system dynamics together with this, or you see some significant differences that you think, okay, is it enhancing anything? Is it bringing anything new, or anything?
Tasso, I guess my question would be, what are your experiences using this technique with actual clients who aren't necessarily system dynamicists,
right,
relative to not using this technique?
What's the last part? I'm sorry, I missed it.
Relative to when you hadn't developed this technique and done system dynamics, and then now you're using it, what's the difference with clients?
Right, okay. What I see, there are many people like numbers. So many people are more attracted to numerical simulations, which brings them to system dynamics. And of course, I refer them to system dynamics straight. But what I see, the difference I see with people who challenge themselves with understanding the system and practically wanting to see the plan and how the plan works, this formality of the plan, I think for those few people, they're not many really. I mean, most of the people, they just want to close their eyes, just give me the plan, make sure it works, you make sure it works, I don't want to know how it works. So the very few people who say, okay, show me how it works. I think that gets them to at least to check, to understand, and that, you know, the previous picture that I showed, the plan view, I put it back again. This plan view, for example, this, I think it's what, for those people who like to see whether their plan or how the plan is going to work, this kind of view or contribution will actually, it satisfies them. But as I said, there are not many of them. Now, I don't know, I have a question for you, for all of you actually. Do you think a system dynamicist who is very comfortable with numerical simulations might ever have a wish to see a formal plan like this? Or not?
Yeah, for me, what I would see is after the simulation, like documenting and the kind of solution proposal, you know, from the policy, because you can update your model from a simulation, system dynamic simulation. You know,
right.
Instead of, as you said, you know, for some clients who don't like numbers, they want to see, you know, a qualitative policy, not always written in text, but, you know, having a visualization. This might
Pathways, right? Pathways. For people who want to see pathways, right?
Yeah, people who, for example, they don't like to really, they're not comfortable with numbers. To have like a visualization kind of system thinking out of the system dynamics model when they already find out, you know, like policy proposals. So this can be, you know, documented, use this diagram as a documentation for senior level executives.
Okay. Yeah, it makes sense. So what you're saying is perhaps this would be more natural to people who are systems thinking rather than system dynamic.
Yes, I would say so. Yeah.
Okay. Sure. It's an idea, I guess. Thank you. That's Jim, right? Also,
Suleiman.
Suleiman, okay. Sorry, I cannot tell who's speaking because the pictures are off. The video is off. Right.
Yeah, Tasso, this is Mike. I think one of the challenges in system dynamics modeling, or for that matter, I suppose any kind of simulation modeling, is to get buy-in from the stakeholders, and moreover, get stakeholders who didn't help build the model to buy in.
Sure.
I mean, it's a challenge whether you're using system dynamics or really any tool, I suppose. And so to the extent that your approach can enhance the understanding of the stakeholders, the buy-in of the stakeholders, because it's in a format that isn't so engineering-ish or something. I don't know what the word is. That would be valuable.
Yeah, I guess, if the stakeholders agree to sit down, yeah, sure. I suppose, this is, it's an invitation for them to pitch in and perhaps debate. But then again, what I've seen in stakeholders, for example, in the public sector, the stakeholders, either they shy away from something like this, or they claim they're busy, basically. So they are busy, very busy.
Yeah, well, right, because you know, the traditional problem has been, you know, going from sort of an academic exercise to something that Jay Forrester always wanted, make the real system better, right? And that's the tricky part. We know how to do all the technical stuff, right? But the people part, right, that's difficult.
People, exactly. I agree with you, Mike. It's the people part. And now we're trying, at least my challenge is to make things simple for people to participate. And okay, if they always claim they're busy, which means I don't want to do any of that, don't push me, don't make me say things in public. That, I don't think the tool will make any change here. But if somebody is has a little bit of a wish, the tool might invite them in a sense. But it's still, the people, I agree with you. The people is the huge factor here.
I have a question, and this is related to the modeling process.
Okay.
Do you use these tools and techniques during, let's say, a group model building setup, or it's in phase 2, you know, after you meet the client and capture the understanding of the problem, and then you use this tool and technique in your modeling?
Good question. Thank you. This is Suleiman or Jim?
Yes.
Suleiman. Right. I have used it in 2 different ways, and it depends on how prepared the team is. For example, with academic colleagues, we're on a project of, let's say, of improving a certain degree of a teaching degree. The colleagues expressed themselves and they said, we want this and we want that. And they even wrote a little note. Each one wrote a little note. And then I had to go away and put things together of what they said. I think the limitation here was not the understanding, but it was the time of the meeting. This is one way. I didn't like it so much because I had many questions and then I had to go ask each one, and perhaps, well, then we had a global presentation that things slacked off, actually. This was not my best experience, but my best experience, on the contrary to this, which I have been working with a number of young engineers, young at the age of, let's say, 30, early 30s, 3 or 4 of them. And these young engineers they're very comfortable with how the system works. They know. So we did that live. We did the diagram live in a number of sessions because it was a large diagram. So what we did is we started with whatever they thought should be had more priority, and then we drew that. I prettified that on a diagram on the software. Then we had the second meeting. We corrected, we added, and we had maybe 6 or 7 meetings, hour and a half each, and then we had the whole system pretty much all collectively created. That was the best experience, I guess. Depends on who is participating and how much time they allow for this, or how much exposure they allow themselves to give. If somebody is comfortable with what they know, they don't mind. You probably know that in live sessions as well. You've seen it probably. If they're comfortable with the system, they don't have anything to hide, or if they understand everything, sure, they will do that with you on the spot. And if they don't understand, if they don't want to show that they don't understand, they're busy.
Yeah, thank you.
Sure, thank you. These are, okay, good. Practical questions. I believe we share the modeling experience, know it? But
Yes. Thank you for teaching us something new.
okay, well, I hope you kind of liked at least the different flavor of system dynamics, or a company of system dynamics. I feel comfortable with, with having system dynamics on my side, and frankly, the way I connected, or why I would like to connect again with system dynamics is because I don't find too many systems people around there. So I was a bit, okay, I was hopeful in the first years, and then I was feeling a bit lonely that there's not many systems people around here. So I'm back.
Yeah, we are here.
All right, good.
Yeah, that's great, Tasso. And yeah, I think this sort of thing is very important. I think we're always looking for new ways to engage the people who are going to have to change their behavior based on model-based insights. And there's a lot of sort of social, psychological stuff going on and what have you. And any techniques from other disciplines or what have you that we can draw upon that work better, I think that our field is all ears. And, if we get some wins on the scoreboard, we want a teachable, repeatable process that we can, show to other people. So your work, I think, is quite important.
Good to hear, Mike. I'm very glad. Okay, I also feel the same, that there's a lot of work to be done around these people, social and psychological factors. And well, hopefully, I don't know if now you know a little bit about this, and I'm always open. I'm busy, but I'm always open to new challenges. So if you think that something of what you heard today or what you saw might trigger, let's say, curiosity or kind of maybe a little facilitating the contacts, I'll be willing to I like adventures, so just let me know if you think any of that might be enhancing modeling experience or getting people to get involved.
Yeah, that's great. And of course, Christina is recording this, and we'll have our doctoral students usually watch the sessions if they're unable to attend in person. So I'm other interests among our students because they are mid-career professionals, as I mentioned, by and large, and they are dealing with working with in the military or whatever with fairly high-level folks and try to get them engaged with these tools, and they're always looking for new approaches to doing that. So.
Great. We'll stay tuned. Exactly. Thank you very much, all of you.
Thank you.
Christine.
Yeah, thank you so much, Tasso. We really appreciate your time and effort.
Thanks, my guy. I appreciate all your company and your feedback, and I'm really very glad to be here. Christine, it's 4 o'clock. It's yours. 4 o'clock for me. It must be 11 for you.
Yeah.
All right.
So I'll stop the recording. Okay. Thank you.
Thanks.